very much. Hi, everyone. My name is Ozioma Oguine. I'm a graduate research assistant at the University of, start this over. I'm a graduate research assistant at the University of Abuja, and I'll be presenting today with my colleague. Yes, and we'll be presenting on the topic AI in telemedicine and appraisal on the deep learning-based approaches to virtual diagnostic solutions. So, personally, before I go into some preambles, I would just like to highlight the main motivation for actually taking out carrying out this research on this topic. So last year in 2021, I went for COVID test at a hospital here in Nigeria. I went with my parents and my siblings. So on getting to the hospital, I noticed that there were more patients than there were medical practitioners in the hospital. So I took out time and I, interacted with some of the patients, and I was able to discover that some patients who were in the hospital were there for minor medical reasons, which I felt like in most developed countries could be sorted out by virtual solutions. So, and as such, it prompted a research on how underdeveloped and developing countries could actually, reasons why they should actually adopt AI in telemedicine and why they should adopt it, stating the importance of AI telemedicine to developing and underdeveloped countries. So some things to note before the presentation are why artificial intelligence in telemedicine? How has AI impacted telemedicine?
We'd also be looking at a question where can the adoption of AI in telemedicine improve medical healthcare system? And also, what are the perceived prejudice in adopting AI in telemedicine?
Okay. So we'll go into a bit of background on healthcare, modern healthcare, and AI. Why AI? So basically, we've seen that healthcare and modern medicine has seen relative advancements in recent years, given the number of research that have been put into developing probably medical solutions and more advanced medical methodologies. A recent upturn in the world health, which happened 2020/2021, which was the COVID-19 pandemic, has seen a turnaround and more resources being invested in the field of medicine by in the improvement of the field of medicine by employing artificial intelligence and deep learning frameworks. Now, artificial intelligence and its resonating research areas such as telecommunication, information technology has stirred up advanced solutions regarding discussions and advanced solutions regarding human health on a global scale. Like I just mentioned, the COVID-19 pandemic was the reason why people had to seek alternative methods toward providing healthcare, given that social distancing was a reality we have to cope with. A foreseen problem in the healthcare system of underdeveloped countries, like mostly African countries, especially in the medical sector, is a significant decline in the quality of the services, healthcare services provided, and the delivery mode of those healthcare services. So we can see that during the COVID scenario, for instance, more people visited health centers for testing, and people who were sick were admitted into hospitals. And as such, medical practitioners were overspent. Medical resources were overused. Medical infrastructures were actually unavailable in most countries to actually deal with these issues and provide orientation and probably medical advices to patients and users of medical devices. So That problem is what this research seeks to bridge, the gap between the quality, the gap in the decline of the quality and the delivery mode of medical solutions. So before we proceed further, I would like to define some key concepts which would be very, very vital to understanding this research. Firstly is telemedicine. What is telemedicine? So this research, we define telemedicine as a global healthcare infrastructure stemming from notable convergence of machine learning, robotics, telecom, computational neuroscience, and cloud computing, all together in the field of medicine. So you have, just to tell you that telemedicine is a combinatory or an ensemble of various computing research areas, all fused together to bring about medical solutions or to improve the state-of-the-art medical facilities or systems available. Now, that is telemedicine. Second on our list is deep learning. For most of us who are researchers in AI, we've either used deep learning for one problem or the other. Now, deep learning has gained quite a very good prominence in the field of computational development and development of computational processes because of its ability to actually handle huge amount of data and draw patterns and inference from those data. So deep learning is a viable approach to every endeavor of our daily lives because of its very improved and notable capabilities. So deep learning, according to this research, can be referred to as the modern state-of-the-art mechanism to computational processes applied to solving contemporary problems. Yes. So we'll move to the last concept for this presentation, which is virtual diagnostic solutions. So virtual diagnostic solutions is a modern day tech, and it's, to most people, you could actually see it as a cyber physical systems, because most of us who use iPhones, for example, have smartwatches that help maintain your heart rate, that help monitor your blood pressure. We use devices that help, we have devices that help check for high sugar levels and several other medical parameters. So virtual diagnostic solution is defined as a systematic approach to undertaking medical prognosis and administering or preferring medical solutions with little or no supervision from medical professionals. Just like saying, you could actually go take your, measure your blood pressure, or take your readings, like monitor your heart rate by yourself without necessarily visiting a hospital or without the supervision of a medical practitioner or professional. So those are basically virtual diagnostics solutions. So
in our next presentation, we'll be looking at telemedicine infrastructure and components. It involves the overall requirement for setting up and facilitating an efficient telemedical infrastructure. In this diagram here, the diagram shows the relationship between telemedical infrastructures and the components. Telemedical infrastructures and components. Outside of this circle here are the various components of telemedicine, where you have the remote clinics, the patient, the home, the ambulance, the medical equipment, physicians, and hospital. And then within the cycle here shows the telemedical infrastructures. This diagram here shows patient and telemedical devices that transmit patient vitals. There is, they get patient vitals from the patient and transmit it into the cloud computing platform for storage and possibly future retrieval, and which can be used for medical health informatics and medical analytics. While on the other hand, on this place, the patient sends out information to a medical professional, which is at the end of this device, and in turn, the information sent out, the medical information sent out by the patient through these devices are being backed up by the cloud computing platform, which can be used for future analysis and predictions and future reference. Now, from the figure, we can see that each component explicitly relies on each other for efficiency and telemedical infrastructure. Medical data are collected from medical cyber-physical systems, are retrieved through the Virtual Diagnostic Solution and are stored on the cloud for future analysis and data retrieval.
Okay, so the next slide on our presentation is going to be talking on the stakeholders involved in telemedicine. Now, for the efficiency and the effectiveness of the research field known as telemedicine, there are certain stakeholders who need to participate fully for this whole infrastructure to work efficiently. So the first on the list is the patients. Now, we regard the patients as a key stakeholder because telemedical infrastructures are actually patient-centric in the sense that every effort and every research and every solution put out are to ensure that the patient's medical needs are being met. So the patients are regarded as either the receivers or users of healthcare services. And like I said earlier, they're perhaps the most important stakeholder to consider when developing a telemedical infrastructure. And the second on the list are the medical professionals. Now, they are the next most important stakeholders in telemedicine. And this is because their knowledges and research lay the foundation for building telemedical infrastructures. Now, in as much as we would want to agree that AI has grown so advanced that we have robots who can do things themselves, there is still the need for medical practitioners to still contribute immensely to the advancement of those artificial intelligence systems. Because without the knowledge from the medical practitioners, the system is basically input and output. So whatever you tell or whatever the machine or the AI mechanism has learned is the only thing that the machine can do. So you need people who constantly conduct research to improve the state-of-the-art machines being used for medicine.
The third stakeholder we'll be discussing will be the developers and the tech experts. These are the stakeholders necessary for the development and the design of these AI systems. They consider the user requirements and the information obtained from patients and possibly the medical professionals to design an interface that can be used to preferring medical solutions for patients. The fourth stakeholders we'll be considering are the policymakers. These are also very key components of stakeholders involved in telemedicine. They are the ones who set regulations, standard, and ethics the use of artificial intelligence in medical healthcare systems are being implemented. They also ensure that there is transferability and transparency and explainability of AI usage in medical healthcare system, particularly when being established on patients.
So we'll be moving to a next slide, which highlights notable AI advancements in the field of medicine. Now, as most of us would know, I've realized, in most developed countries, we have quite advanced number of medical processes, unlike developing or underdeveloped countries. So we would sort of like buttress on the developments that are going on in developed countries and why, and see reasons why the underdeveloped and the developing countries should speedily try to follow suit so we can meet up with the medical needs of modern day medicine. And first on the list, advancement in medicine is analytical medicine. Analytical medicine just basically involves use of data analytics to prefer better solution to medical needs. So as more and more data are being generated in our current society, there's a need to sensitize, collect, aggregate, review, and sort of derive insights from the huge amount of data generated on a daily basis. And as such, we can use those information and insights to provide several medical solutions to patients. So analytical medicine is top-notch because it goes a long way in ensuring sustainable patient medical practitioner relationship. By knowing what your patient or the medical condition of your patient, it just helps you prognose and diagnose for better medical solutions. Next is robotic surgery. Robots are being used in modern day to conduct surgical processes and are seen to be very efficient because of the elimination of bias in their computation or in their knowledge base. The next is DNA sequence analysis or genomic sequence analysis. So deep learning approaches such as the LSTMs and neuron DNNs, the deep learning neural networks, are being used to sequence DNA analysis. So they're being used in biomedical sciences or biomedical engineering to see how the structures and the composition of a makeup of a person, that's the DNA of a person, could influence certain environmental changes or behavioral or even medical changes. Yeah, so the next is drug research and discovery. So deep learning and AI has generally improved the field of drug research and discovery as more modern drugs. For example, we could see the case of the COVID-19 pandemic, where we had like 3 separate vaccines that were made for the COVID-19 vaccination process. We had the Johnson's & Johnson's, the Pfizer, and we have the AstraZeneca. So we also had Moderna as well. So these different companies probably will use different methodologies to improve and probably come up with a useful vaccine to treat the pandemic. So the next on the list is medical data security. So just like my colleague has just said earlier, given there is constant interaction between medical professionals and patients, there's always a need for medical data security because it's important, it's top-notch on the security infrastructure, the confidentiality, integrity, and accessibility are being maintained whenever there is interaction between 2 parties, a network or a communication. So medical data security is a key part that has grown over time. And the creation of cloud spaces has improved the database storage capacity of most medical hospitals and most medical systems. So that is another field. Clinical trials has also been advanced by through the incorporation of artificial intelligence in the processes. Medical risk prediction is another area. Emergency services has literally grown through the implementation of IoTs. Now, these days, if a patient should have like a heart attack, if you're using certain phones or devices, it could immediately send out signals to hospitals or to ambulances, calling them and letting them know of your medical health or health status at a particular period of time. So that is another field that has grown with the advent of AI. Medical image analysis is one that is so important, and I think has gained widest research, widest growth, in the sense that brain tumor, computer tomography, and radiology has advanced through the employ of computer vision algorithms and computer vision models in faster detection. We can see the use of the SSDs, the CNN, the more advanced state-of-the-art models for medicine in medical image analysis.
We'll be looking at a literature review on deep learning in telemedicine and previous studies that have been conducted to further improve the deep learning in telemedicine approach and algorithms. One of the first one is effective telemedicine security using wavelet-based watermarking. The research was conducted in 2016, which was focused on information technology, including information retrieval and medical image analysis, and ensuring confidentiality and privacy in a cyber-physical system. The next one is mobile cyber-physical system for healthcare functions, ambient ontology, and e-diagnosis. This research was conducted in 2016. It was used particularly for patient monitoring. Detection of fetal electrocardiogram through OFDM. neurophasic logic and wavelet system for telemetry. It was conducted in 2016 also. It was used for patient monitoring. It employed neurophasic logic system to detect the exact electrocardiogram signals from fetus in the abdomen of a pregnant woman. We'll also be looking at subsequent research which was conducted using CAT for advanced prediction of asthma attack based on telemonitoring data. This research was conducted in 2016. It was used for intelligent assistance diagnosis. Lastly, the literature we'll also be reviewing was a wireless continuous patient monitoring system for dengue. It was conducted in 2017 and it was also implemented for patient monitoring.
So there was a very significant need to review literatures because we needed to understand what has been done. You must know what has been done or what has been implemented before to know where you would go from there, or to know how the current study would improve future prospects. So as such, we'll talk about the documented implementation of deep learning in telemedicine. So deep learning has gained a very good prominence, like I said earlier. It has gained good application as well in most fields. Most importantly, medical research areas. So I'm going to be talking about, we're going to be speaking on some areas, some greatly impacted. And the first is medical imaging. Okay, medical imaging just mostly entails training AI models with images of medical scans that have been scientifically collected and stored in data repositories and databases. We have repositories such as Kaggle and several repositories you could get medical images from and scans. So you would use those AI models to train, or you use those images to train your AI models, in the sense that when they have learned and the learning of those models are being validated, you could use that model in the future to test and see if it will be able to predict most of all those medical illnesses or ailments, given future medical scans or medical images. Here we can see an example where we have an X-ray scan that was conducted in 2021. Now, an SSD, multi-box SSD model was actually used to make diagnosis of COVID-19 from this medical X-ray scan. So the model learned, given training data sets, and later on were used to make predictions based on new data that was provided, test data that was provided to it. And from our research, generalization capability of this model was very efficient, in the sense that it was able to spot patients with COVID-19 through X-ray scans. So the next on a slide will be the screening for neurological conditions. Now, this is another area that has gained prominence through the application of artificial intelligence. Now, several AI models are being developed and employed in speech pattern analysis to predict psychotic episodes, schizophrenia, and recognize and monitor symptoms of neurological disorders such as Parkinson's disease. Now, there have been several implementations of AI to detect patterns from speech, to recognize ailments such as psychosis and schizophrenia. As we can see from the figure in this slide, now this shows healthy brain scans, healthy controls, and this the second figure shows first episode of psychosis. We can see the coloring in the brain scan here has a bit of yellow red, and we can see the first episode of psychosis display red signs in the red colorings in the brain. So we used medical deep learning approaches to improve the detection of and screening of neurological conditions.
Deep learning approaches can also be implemented in echocardiography, which is used to study the heartbeat pattern and diagnose coronary heart diseases and other diseases of the heart. AI framework known as autonomic system TRIDE was used to analyze the echocardiography of echocardiography scan as shown below. These are the various level of echocardiography scan implemented using a deep learning model to actually deduce patterns from these medical image scans and to help in medical diagnosis and make informed medical decisions. Deep learning can also be used for emotion recognition in psychological prognosis. It can be used by psychologists. An effective model implemented can be used by psychologists in detecting the facial emotions of their patients and also detecting a slight shift in the facial emotions of their patient. This can help them make informed decisions and generally study their patients and know what's next to take. AI and artificial intelligence deep learning models have proven efficient in recent times in observing and predicting emotions through individual reactions, psychological states at a given time. We're able to validate this using an area alias research by us on facial emotion recognition. Now, there are various prospects of AI-based virtual diagnostic solutions in telemedicine. And one of the prospects is early diagnosis of treatments, early diagnosis and treatment. Diagnosis and treatment have ensured the advancement of research conducted in the field of medicine. Of recent times, AI has been able to help medical professionals make diagnosis of medical conditions as quickly as possible, compared to when a team of doctors will gather together to make these decisions. AI has made it possible for these diagnoses to be made at a faster rate, and this will help to save time, help to save life also. Telemedicine has also been geared towards establishing and improving early diagnosis and treatment mechanism for numerous medical conditions. Now, patient independence. If we see in recent times, one of the benefits of AI has given patient independence to take control of their own health. It is one of the key gaps identified in traditional medical system, the inability of patients to get access to free medical health facilities, especially in low and middle income countries. Now, AI has helped to bridge the gap of patients' access to health care. It has been implemented in such a way that deep learning approach have helped to make patients feel empowered, thematically, objectively, and also evaluate symptoms, preferring possible solutions through virtual diagnostic systems.
So we have improved clinical and therapeutic process. So not only have the efficiency and advancement in AI ensured, not only has the efficiency and advancement of AI ensured quality in the level of medical potential, but they have also shown a remarkable promise in the level of service delivery mechanisms. As more implementations of virtual diagnostic solutions are utilized, huge amounts of data are also generated from healthcare professionals and patients. Over time, this aggregate amount of data will create an abundance of information of stakeholders involved in telemedical utilization. So as more and more data are being generated from the telemedical softwares and telemedical applications, these medical data will be extracted, patterns will be drawn, and as such, we can have a knowledge base where these machines and models will be able to help us make future predictions. We'll be able to analyze our medical status at a particular period of time, and also be able to create certain prognosis or diagnosis with a possible means for medical solutions. The last remarkable part or the remarkable advantage of AI in telemedicine is scalability. Okay, global healthcare witnessed a new dawn with the discovery of telemedicine, because they showed that medical solutions could be provided outside hospital buildings. Now, this importance was a major one for me, because I like I said earlier in my scenario painted, I was at the hospital and I saw people filled up in a hospital, or everyone trying to get medical services. And at the end of the day, most people were not giving such services, with everyone having to return home with your medical ailments. Now, I felt like if there was priority in your ailments, then you should know with major ailments or serious ailments, you'll be given higher priority, and as such, you can report to the hospital. But minor ailments, minor diagnosis or minor prognosis can be given to patients at home. And as such, you would not need to overstretch or overutilize the facilities or infrastructure available at the hospital. That is for traditional medicine. So virtual workflows and technologies have been set up over time to create optimal infrastructures to implement this process. That's a process of scalability. We have softwares, we have applications, even more recently on mobile phones, but Android devices and Apple devices, there are softwares that are used to improve your health through detection, through monitoring, and through diagnosis or prognosis. So another reason for improvements in scalability in modern day medical infrastructure is the ever-changing needs of healthcare stakeholders to meet state-of-the-art next-generation service level requirements. Now, there are several things that has improved in the last 5 years in the field of medicine. For example, what was in 2015 or 2017 might not necessarily be applicable now. For example, the case of COVID-19, there were many services which most developed countries started providing virtually rather than you having to visit the hospital due to the social distancing rule that was applicable at that time. So as such, scalability has made AI an efficient tool in telemedicine. So for most developed and developing countries, these advantages are things to look out for that will prompt or necessitate the improved and fast implementation of AI in telemedical infrastructures, if available. Now, if not available, there is also a need for telemedicine to be implemented in medical systems in developing and developed countries.
Despite the numerous benefits promised by the integration of AI in virtual diagnostic systems to provide geographically accessible and affordable, acceptable and quality healthcare, there have also been challenges mitigating its full adoption and development potential. Firstly, the high cost of the virtual diagnostic system is a key problem in the implementation of AI. Although virtual diagnostic systems have been leveraged to reduce the high cost of healthcare and accessibility, this is only valid for patients' perspective. While this issue might seem improbable, in our contemporary society, it is permitted to note that cost sums up the general resources required to develop, implement, and advance virtual diagnostic system. Furthermore, in low and middle income countries, the implementation of AI can be close to impossible, reason being that the rate of poverty in low and middle income countries is high, and then it makes patients unable to access and get these devices needed for them to access a virtual diagnostic solutions or leverage the benefits that AI can provide. Secondly, the unavailability and underdevelopment of technical infrastructures. Technology and communication and artificial intelligence advancements are the backbone of functioning state-of-the-art medical solutions. As we have elucidated earlier in sections before, as we have elucidated earlier in sections, the robust nature of telemedicine has necessitated the requirement for sophisticated infrastructures to ensure an effective development, and deployment. Like I said earlier, the unavailability and the development of technical infrastructures in the African region, not just the African region, but also in developing and underdeveloped countries, it makes it impossible for them to leverage the benefits that AI in telemedicine can produce or can give. Thirdly, we have reliability issue. One of the significant concerns regarding the adoption and implementation of virtual diagnostic solution is its reliability and generalization ability. Given this issue, several virtual diagnostic systems have come under severe scrutiny, raising questions and sentiment concerning their utilization. Also, it is impossible to rule out the cases of biases in the virtual diagnosis system in terms of gender, in terms of race, because some of these systems are built with a specific data set specific to regions of the world or specific to specific regions of the world. And now the generalization ability of such systems to be implemented in other regions of the world, like Africa and other places of the world where the data sets do not match, it becomes a problem. Now, reliability is a dominant parameter in determining the rates and adoption and research in telemedical solutions.
We're going to be talking about more challenges that applies to the implementation of AI in telemedicine and the implementation of telemedicine as a research field in underdeveloping and developing countries. So another key challenge in implementation of AI in telemedicine is ethical violations, confidentiality and privacy issues. Now, I stated this earlier that there is a need in the communication systems for protocols and ethical rules and regulations to be established to ensure efficient communication and syncing between all the parties or stakeholders involved in that system. So ever since the revolutionization of the internet, privacy and ethical policy stability has been a critical challenge among internet users. Just like medical professionals, patients, as the virtual diagnostics users, need orientation and training on data access, privacy, and protection measures when utilizing services on virtual diagnostic solutions. For efficiency of telemedicine, data privacy such as doctor-patient confidentiality, training, licensing of personnel is expected to be strictly adhered to. Now, for an efficient telemedical infrastructure to work, you would need certain privileges, certain data to have limited access to parties who are supposed to access those data. Now, we should also want to know that security from cyber attacks and other information attack could also hinder the progress of AI in telemedicine, as most of this infrastructure, most of the components in the telemedical framework could be exploited, and as such would cause such damage to either the medical professional or to the patient. So you would always want to mitigate against this by ensuring proper security of the AI or telemedical infrastructure. The last on the list of challenges observed from our research is continuity and sustainability. Now, recent global pandemic has necessitated the sustainability of advanced medical technologies. As more medical issues arise, so should the pervasiveness of healthcare approaches employed for treatment purposes. So a major drawback, especially in underdeveloped and developing countries, is their incapability to adequately sustain and encourage advancements in telemedicine, even through research or system analysis. Now, this is really practical because we see countries like the United States of America, the United Kingdom, and most advanced countries invest hugely into research and funding so as to help improve most of the available amenities into state-of-the-art capabilities. So now this inefficiency on most developing and underdeveloped countries has caused a steady decline in our advancement, because you cannot move forward, you cannot take a step forward and take 3 steps backward, and you still expect to be ahead. So AI in telemedicine has witnessed a drawback in terms of sustainability, as much efforts, or most times little efforts, are even put into ensuring that the infrastructures already available are being sustained and advanced to the next level. So this is a major challenge that this research observed in most developing and underdeveloped countries. So we have would be concluding this this presentation by saying the overall significance of this paper is to throw more light on the importance of deep learning-based AI methodologies in advancing state-of-the-art virtual diagnostic solutions in medicine. This paper also seeks to buttress on the challenges that will be faced when implementing or employing or utilizing AI-based telemedical frameworks in several modern societies. So would also want to encourage future work, because on the process of conducting this research, I figured that little or no research is being done in the field of advancing virtual diagnostic solution as a research field, or telemedicine as a research field. So, so for future work, I would like to encourage more researchers to, invest more time, invest more resources to seeing how AI can be implemented in telemedicine and the future that telemedicine has in our society. Thank you very much for listening. We greatly appreciate the time. Yes.